Managing Battery Energy Storage System Temperatures with HVAC Design, a short video featuring Dr. Kevin Linfield. Demand for electricity is highly variable and influenced by numerous factors, which can make it difficult for utilities to optimize their generation output. One solution is LowLeveling, in which generation units run at a more consistent output, and surplus energy is stored when demand is low. When demand increases to peak levels, the stored energy can be discharged. A battery energy storage system, or BESS, is one method to store surplus energy and respond to variable demand. However, one characteristic of a typical BESS is that battery temperatures increase significantly during peak discharge cycles, which could lead to unit failure or even a fire. Careful thermal management is essential to avoid overheating. For indoor facilities, this means that the HVAC system must be capable of delivering cool air to the batteries to keep the modules at acceptable working temperatures. When designing a new BESS facility, thermal management is a concern. In order to evaluate the duct design and the cooling capacity, design analysis should include a computer simulation of the room ventilation system using computational fluid dynamics, or CFD. The modeling starts with the construction of a 3D CAD model of the BESS facility interior, including the racks and modules, the HVAC ductwork, and the cooling air outlets and return duct openings. Each group of battery racks is mounted inside a cabinet with its own internal cooling fan that pulls room air in, then exhausts the heated air out through a series of vertical openings adjacent to the racks. An example CFD simulation of air flowing through a room is shown. It takes into account the temperature and velocity of the air as it enters the room through the HVAC system and follows the flow as it enters and exits the battery units. The return air vents pull warm air out of the room and back into the cooling system. Throughout the room, the model incorporates the thermodynamic effects of the flow, calculating the temperature changes to the cooling air as it warms up inside each battery cabinet. The computer simulation predicts the air velocity, flow direction, and temperature at any location within the facility. With these results, designers are able to explore the room HVAC design. Simulations can reveal room hotspots or system energy waste due to recirculation or bypass air. Ultimately, the outcome of performing CFD analysis is a more effective design. For more information on flow modeling and field testing, please contact Airflow Sciences. Thank you, and have a wonderful day.